So it looks like we have a chi-square and evolution problem. So we have a population of flies. 54 have long antennae. Let me just start to write this down. This is before. So 54 long antennae, 20 medium antennae, and 28 with short antennae. And then after decades of selection pressures from predators and parasites, new population. So let's get these new. So our after. So now we have 48, 24, and 29. So wants us to calculate the chi-score and state whether the population has significantly changed. Well, now let's digest this for a bit. So this is our before, this is our after, and so after is what we observed. To long, medium, short. So this is what we saw after the selection pressures. Let's add these up to get a total. So our population after is 101. Now, what we expect it, if there's no evolution, we expect to see basically what we had at the beginning of the population. If there's no evolution, then we expect the conditions to be pretty much the same before. But we have to control for the totals. Let's make sure that the totals add up. So this is, oh yeah, this doesn't look like it added up. 102. Let me check my math up here, make sure. Yeah. So we have a snafu here. We would like to just plug these numbers into expected, but the numbers don't add up to the same. So we have to get the same percentage in our expected that we had before, but since it's not the exact same population, we need to account for that. So we expect the same percentage. So we expect 54 out of 102. We expect 20 out of 102. And we expect 28 out of 102. Now we have to convert these into percentages. So we got to convert these into percentages. So 54 divided by 102 is 0.52, so that's multiplied by the 100 to get percentage. So that's 52.9%. And let's do the others. So that's 19.6%. And then we have 28 divided by 102 is 27.4. I'm just going to round that since we have the 5, so we're going to say 25.5%. So these are the percents we expect to get if we have 102, but we don't have 102. We actually have, if we looked at our observe up here, we have 101. So we have to find 52.9% of 101. That'll give us our expected for our long, and then 19.6% of 101 gives us what we expect here, and then 27.5% of 101, that's what we expect to see here. So let's do that math. So the first one is 52%. So a good way to do this is to convert that back to a decimal. So 0.529 times our total population, 101. So that's telling us we expect to see 53.429 of them to have long antennae. And same thing for, so 0.196 times our new total, 101. So that's 19.796. And then again, 0.275 times 101. So that's 27 organisms, 27.775 organisms. I know you're wondering how can we expect point organism. We can't, but we're just going to plug those numbers in for consistency reasons. So now let's just do our observed minus expected. So we have 48 minus 53 point, let's say 429. So it's negative 5.429. Same thing here, 24 minus our expected, 19.796. That's going to give us 4.204. And then the last one, 29 minus 27.775. That's 1.225. Then we have to square these numbers. So we have, notice I'm not putting in times 5.429. I'm hoping that's what it says. I can't read my handwriting. So that's 29.47. I'll just go 3 decimal points to be consistent with what I did here. Notice when I squared it, I didn't plug in the negative number because I already know that a negative times a negative is a positive. So no need to do that here because I know this is going to be a positive number. In fact, the reason why we square it in chi-square is so that we get rid of any negative numbers. So now I'm going to do 4.204 times 4.204. So I squared that number. Well, it looks like I'm going to round this up because of that 6 here. 1.225 times 1.225, 1.500. Well, we're going to again round that up. So that's 6. Now I'm going to divide these by expected. So 29.474 divided by what's expected. That's up here, 53.429. It's going to give us 0.55. I'm going to round that up to 2 because I know the chi-square chart goes to 3 decimal points. Or actually it only goes to 2 decimal points. So I'm going to, well, we'll keep it there, that's fine. 17.674 divided by expected, which was 19.796, and that's 0.88. Round that up to an 8. What's the next one? 1.501 divided by expected, which was 27.775. So now that is 0.054. Now let's add these numbers up. So we have 0.552, I'm adding these numbers, plus 0.888 plus 0.054. That gives me 1.494 as my chi-square number. Now I have 3 categories, so we got the degree of freedom is number of categories minus 1 gives us 2, so we know we're looking at this row. This row up here, the second row. Look at my cutoff point. So at row 2, cutoff point is 5.99, and my chi-square is much smaller than that, 1.4. So I'm actually on this left side. I'm actually somewhere like over here, which is non-significant. So calculate the chi-score, that's 1.494, and state whether the population has significantly changed. No, the population has not significantly changed. Therefore, no evolution, not significant difference.